Hello, ladies and gentlemen. All right, so we're going to be moving on from triangles now. We're going to move on to some quadrilateral proofs. Okay, starting off with parallelograms. Okay, so as part of today's notes, I attached a new document for you to look over. Okay, it's called Pathway to Success for Parallelogram Proofs. Okay, so if you want to just look through this, and it'll give you some tips that you can use. I'm not going to read all this to you, but that is another resource at your disposal. If you want to print it out, that would be a good idea. Print it out and have that, next to you when you're doing this stuff, something to refer to, or keep it on your Google Drive and just open it when you need it. Okay, and also the pathway to success for proofs. Okay, we talked a little bit about some of this yesterday. The parallel lines. Okay, forming alternate interior, corresponding, or alternate exterior angles, and all that. Okay, so we're going to be talking a little bit more about that today. All right, so I just wanted to get into a quick example here of a proof and talk about some of the things that I wanted to emphasize. Okay, so if you're told that a figure is a parallelogram as a given, okay, that's what we're going to start off with. Parallelogram is given. Okay, down here it's parallelogram. You have all of those properties that we talked about many months ago of a parallelogram that you can use, okay, to prove that it's a parallelogram. Okay, opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, diagonals bisect each other, all of those things. Okay, and those are all, again, they're kind of summarized on this document here, the parallelogram proofs document. All right, so what do I want to prove? I want to prove that G is the midpoint of FE. Okay, so I want to prove that that G in the middle there is the midpoint of that FE. Now, FE is not a diagonal. Okay, so you can't just say, oh, it's the diagonal, it's the midpoint, and the diagonals, intersect at the midpoint. FE is not a diagonal, so we can't do that. All right, so we're going to have to figure this out using congruent triangles somehow. Okay, so what I'm going to do is I'm going to focus on one pair of triangles that we have here. There's a bunch of different pairs that I could use. Okay, but of course the pairs that I need to use have to involve FE somehow. Okay, so I'm specifically going to focus on this one and this one. Okay, I could just as easily do the same exact proof with these two. Okay, just some of the angle names and some of the segments might be different, but I could do the same thing with those two triangles. But I'm just going to concentrate on GFC and GEA for now. Okay, so I'm going to get rid of all those. Okay, and here we'll start. So I know that this is a parallelogram. So the first thing I could say is that those opposite sides are parallel to each other. So I'm going to start off first with ABCD is a parallelogram. Okay, parallelogram. Okay. Okay, now I ask myself, what do I know about parallelograms? Well, by definition of parallelogram, aren't the two pairs of opposite sides parallel to each other, right? So I can say that this side, I'm going to do it like this. This side is parallel to that side. So that's going to be my next step. So I'm going to say BC is parallel to AD. And this, I can say that is by definition of parallelogram. Okay, again, because by definition, the two pairs of opposite sides are parallel. Okay, if I had said that those sides were congruent to each other, that's not the definition of parallelogram. That's a property of parallelograms. More about that later, but for now, we're just using definition of parallelogram. Okay, so those two sides are going to, since they're parallel, I've got alternate interior, I might have alternate exterior angles, I might have corresponding angles. As soon as I've got parallel lines, it opens up a whole bunch of opportunities for angles, okay? And I can see now that, well, this angle and that angle will be congruent to each other because they're alternate interior, okay? So that's what I'm going to say next. Okay, so step 3 is going to be that I'll call them angles 1 and angle 2. I'll call this angle 1 and this angle 2 just to make things easier. Okay, so angle 1 is congruent to angle 2. And my reason will be parallel lines cut by transversal form congruent alternate interior angles. Okay, now I'm going to look at these two angles. 3, I'll call this one 3 and 4, because those are going to be my next angles. I can call those because they're vertical. Okay, so I'm going to say angle 3 is congruent to angle 4. Okay, because intersecting lines form congruent vertical angles. Okay, next we know that the diagonals of a parallelogram bisect each other. Okay, so that's going to make this side congruent to that side. Okay, so that's going to be my next statement. Okay, that AG is congruent to CG. Okay, and my reason being diagonals of parallelogram bisect each other. So now I can say those two triangles are congruent to each other. So triangle AGE is congruent to triangle CGF. Okay, and I showed that using angle side angle. Okay, so now I can say that EG is congruent to FG. Okay, and that's by CPCTC. Okay, and 8, now that those two are congruent to each other, 8, well, that must mean that G is the midpoint of FE. Okay, that's by definition a midpoint. It split that segment into 2 equal pieces, so that is by definition of midpoint. Okay, so a couple of differences here, right? We had a parallelogram which opened up all of those properties that we could use for reasons for statements, okay, to get the triangles congruent. And, we weren't looking for, specifically to find the triangles congruent to each other, and not even to find the segments congruent, but one step further to find that G is the midpoint of FE. And that's just one more step, okay, to say that that is true once we got the two segments equal to each other. So then that's it for that one. Okay, so in this case, we're trying to prove that AR is congruent to CM. Okay, so it looks like if I get those two smaller triangles on the ends there, on the left and the right, congruent to each other, I can do that by CPCTC. Okay, so that's what I'm going to look at doing. All right, so I'm going to put in my given ABCD is a parallelogram. That's given. Okay, so now I'm going to want this angle and that angle to be congruent to each other. All right, so I'm going to call it angle 1 and angle 2. All right, in order to do that, those are alternate interior, but you got to be careful which sides you say are parallel. Those are alternate interior for AB being parallel to CD. So I got to make sure that that's the pair of sides that I put into my proof. Okay, that's the one that matters for those two angles. Okay, so I'm going to say AB is parallel to CD. Okay, and again, that is by definition of parallelogram. Okay, so now I can say angle 1 is congruent to angle 2, okay, because parallel lines cut by transversal form congruent alternate interior angles. Okay, the next thing I'm going to focus on here is going to be AB being congruent to CD. Now, those are opposite sides of a parallelogram. Now, that's a property. Okay, so be careful. Do not say it's by definition of parallelogram. Remember what definition of parallelogram is. Definition of parallelogram is that the two pairs of opposite sides are parallel. The fact that they're congruent is a property. Okay, so we're going to say AB is congruent to CD, and our reason is going to be okay, opposite sides of a parallelogram, okay, are congruent. Okay, so now we have the last given here, which is that this side AR is congruent to CM, and that's going to give me those two triangles being congruent to each other. So I got to stick that given in there. Remember, all your givens, whatever you're going to use, has to be in the proof. So AR is congruent to CM, okay, and that is given. So now I've got enough to say that triangle ABR is congruent to triangle CDM. Okay, and I did that by side angle side. All right, so now I can state my proof statement. BR is congruent to DM. Okay, and then that, of course, is CPCTC. All right, so that's it for that one. Okay, so the only thing really new here is that parallelogram gives us all of those properties to use for reasons to get parts congruent to other parts, alternate interior angles. We've got congruent, we've got diagonals that bisect each other. We've got congruent opposite angles. We've got all kinds of different properties. And again, they're all summarized in this document that I attached for you. Okay, so make sure you go through that and read through and say, oh yeah, I remember all this stuff. So, but it's a good reference to have when you're working on the homework. Okay, so that's it, and good luck.